In today's video, I'm going to share with you a couple things. The first thing I'm going to talk about is one of our end of the year goals for first grade and kindergarten, and also a little bit of second grade. I'm also going to talk to you about whether this is actually easy or not, why this goal is important, and what are some ways that we use to teach it in class. Our end of the year goal for kindergarten is number sense, adding and subtracting, finding the sums and differences for numbers up to 5. And it is the same concept with numbers up to 10 for first grade. And in second grade, it becomes numbers within 100. It sounds kind of easy. We might have parents or families that might think, oh, definitely my kids got this in the bag. 9 plus 4, 9, 10, 11, 12, 13. They can add more, higher numbers than just within 10. Yes, although students can add 9 plus 4, and that's wonderful and beautiful all in itself, that is not what we mean as in mastery with addition and subtraction within the number sense of numbers up to 10. So is it as easy as it seems? No, it's not easy. And it takes a lot of work, a lot of repetition. That's why it's called mastery. I'll start with what mastery looks like. So although we might think, okay, a student can add 6 plus 4 is 10. Got it. It's really easy. My kid can do 5 plus 5 is 10. They don't even have to count. They just know it. Beautiful. The more that they know all of their 10 facts on the top of their head, the better it is. But not only do we want them to reach this number 10, which is called Think 10 strategy, which is something that we want them to be able to have by the end of the school year. I should have brought an eraser here with me. So here it is. I have a tissue. This works just as well. What we want students to be able to do is add any combination and subtract any combination of numbers up to 10. So for example, if I said the number 7, any two numbers that come up to 7, we want the kids to be able to have it like that. So 5 and 2 is 7. 4 and 3 is 7. 6 and 1 is 7. 7 plus 0 is 7. So we want all the kids to be able to just know it. If I said 6 plus 1, 7. So a lot of kids might get that because it's one more. But if I said 4 plus 3, students start thinking, okay, 4, some of them, they will do 4 in one hand, 3 in the other, and they kind of count those. And it's great. We encourage them to use their fingers. It is a tool for them to use for counting. But the goal is that it becomes automatic and that they no longer need to use their fingers. So for example, if I were to show them this, like this, and if I show this to you, not a lot of people, I hope not at this point, are saying 1, 2. You just kind of know what 2 looks like and you have it in your head. That's kind of where we want our students to be, and how what mastery looks like is that they just know it. If I were to put the number 3 here, does the student know this is 4? And how quickly does the student know that this is 4? If I were to put a 3 here, does the student know that this is 4? And how quickly does he or she know that this is a 4? Also, if I were to put, and like I said, this is any combination. So students are sometimes thrown off if I put the 7 on this side and do this. Do they still know this is going to be a 4? So we want to expose them to many different ways just within the addition itself. And then also we want to look at the differences. So if I were to do this and said some number minus 4 equals 3, do they know that this is a 7? So we really want this mastery within all the numbers up to 7. So that means all the different ways that you can take apart 7, all the different combinations that you can put together to get to 7, all the combinations that you would put together to get to number 8, to 9, to 5, to 4. All of the numbers up to 10, we want our students to be able to take apart and put together without any hesitation. So that is what mastery looks like by the end of first grade. And it's the same similar situation for kindergarten. We want them to have this type of mastery with numbers within 5. that by the time kids come to first grade and they already know all these different combinations of making fives, 4 and 1 is 5, 3 and 2 is 5, or all the combinations of 4 and 0 is 5. That's another thing that throws off kids a lot of times, is that number 0. So that's another thing we want to make sure that the kids really understand, that 0 is also part of that combination. You can add with zeros, you can take away with zeros. So that by the time the kids come to first grade and they have a really good, strong base within numbers within 5, we can just move on and add to what they already know and build that mastery within numbers up to 10. So we will start with numbers, taking apart number 6, 7, 8, 9, and 10. So that by the time they're in second grade and they're really, really master this skill, they can add with bigger and higher numbers. So why is this so important, and how is this helping our students add and subtract bigger numbers? I'm going to demonstrate that to you a little bit right now. So for example, when we have the numbers 8 plus 5 equals, for a student that hasn't yet mastered all the different ways to take apart, add, and put together, and take away these numbers, they might say, okay, 8, 9, 10, 11, 12, 13. So they came up with the correct answer. Beautiful, love it, awesome. So they've used their strategy of counting on. They didn't have to show me 8 fingers and then 5 fingers and count all of them together, which is a lower skill. They knew that this was the higher number and they applied the concept of counting on. Awesome. But a student that has already mastered the Think 10 strategy and all of the numbers of adding and taking apart the numbers within the 10 should do something like this. They already know that in order for 8 to be a 10, they need a number 2, because they know 2 and 8 makes 10. And they also know how to take apart 5 really easily. So they know right away, oh, there's a 3 in there because 2 and 3 is 5. Then they can visually add, 8 and 2 is 10, plus 3 is 13, and that's how they get to this number. Now, this looks like a longer way of doing it. Actually, it's not. It's a lot faster, because this whole thing happens in the student's head. They will come to a point where they can visually take numbers apart and put them together without needing to count or add on their fingers or on paper. They would just know, oh, 8 and 2 is 10. I took the 2 from the 5, there's a 3 left over, I'm going to add the 10 to the 3, and 10 and 3 is 13, which is really easy. And that's why we call it the Think 10 strategy, because it's really easy to add with 10s. So we want the kids to always find a way to make the numbers into a 10 and add whatever is left to it. So this is our end goal. This is going to help us when students are adding numbers that are a lot higher, when they're doing, for example, a number like, 88 plus 5. This is a lot harder, right? But if they already have those mastery strategies in second grade already, they can still say, oh, I already know, I still need this 2 here to make this into a 90, and I already know that there's going to be a 3 left over, 90, and the 3 is going to be a 93. So this is going to be really, really easy, and it's going to help them make their computations a lot faster. And when computations are coming natural, it makes it a lot easier and opens up the space for their focus to be on problem solving and understanding the problem, instead of worrying about how I'm actually going to do these computations. So this is the reason why it's really important. This is what mastery kind of looks like. And now I'm going to show you a couple different ways on how we teach it. So one thing that we do when we're teaching is, of course, in the beginning, the best way to teach it is through using manipulatives. Something that one of my parents purchased for our classroom this year. I love the base 10 blocks. It's a great, fantastic visual. I'm going to show that to you right now. So the base 10 blocks comes with the base 10 units that represent 1. And they look like this. They're really small. 1. Kind of looks like a little itty bitty Lego. They also come with the 10s, the base 10 rods. That's what we call these, the rods. They're a group of 10 together. They also have the flats, which are 100, and the cube, which is 1,000. So these are going to come into play later. In the beginning, we're just going to use the units and the rods. I'm going to write the same problem here. I'm going to write down the 8 plus the 5 equals how many? So what I would ask the students is I would ask them to use their units to show me the number 8. So I'm going to show you what that looks like. So I would say 1, 2, 3, 4, 5, 6, 7, and 8. There's our 8. And then I would say, please show me the 5. 1, 2, 3, 4, and 5. So this is really easy to visually see when I ask the kids, how many more does the 8 need to make a 10? They can see clearly there's 2 spots here that they need to make the 10. So then they could just slide the 2 over, and already they made their 10, and they can see the 3. 10 plus 3 is 13. So this is one way we practice it, by using manipulatives, and they can just visually see if we were doing 7 plus 5, how many more do you need to get to 10? I can clearly see I need 3 more. Move over to 3 from here. What's left? This is a 10, there's a 2, 10 plus 2 is 12. So this is one way to do it. Another way to do it, if you don't have manipulatives, and even if you do, you don't want to only use these, you want to be able to move away from that concept. You can also do the same thing with drawing. If I have the number 7 plus 5, we can draw the 7. 1, 2, 3, 4, 5, 6, 7. And then we'll draw another 5. 1, 2, 3, 4, 5. How many does 7 need to get to 5? 1, 2, 3. Let's move over 1, move over 2, move over 3. What's left? We have 10 and 2. There's our 12. If this is too confusing, you can also have them, I'll just re-show it. You can have them draw out their 7. 1, 2, 3, 4, 5. And always we want them to stop at 5 and come down to draw the rest, because it's easier to count by 5, so you don't have to recount this every time. You just know the top row is always a 5. 5, 6, 7. 1, 2, 3, 4, 5. And to make it less confusing, I can just erase here and put 1 here. Erase this one and add it here. Erase 1 here, add it here. Now that I have my 10, what's left? 10 plus 2 is 12. So this is our way to do it, by just drawing it out. Another thing that we use are number bonds. If you don't have a template for it and you just want to draw it out, you can. We use the part-whole strategy. These are the 2 parts, and that is where we put the whole number. You can use this holding it this way. You want the students to see it in many different ways. You can hold it sideways, part, whole. This could go this way, part, whole. It doesn't matter, as long as you know that the 2 lines are coming to the whole, and these are the 2 parts. You can also change things up by drawing it in the shape of squares. You can do a square with, 2 circles, or you can do the square with 2 small squares. You can make them all the same size. You just want to expose the students to many different ways of doing it, so they have an understanding of, oh, we're talking about the 2 parts and the whole. So if we had the number 4 and 3, so those are the 2 parts, 4 and 3, what's the whole? It's 7. How do we figure that out? We talk about, how can we figure that out, right? We have 4 people that live in this house. They walked over to this party. Let's bring them over. 1, 2, 3, 4. There were 3 people that lived in this house. They came over to this birthday party. There were 3 people. How many people are at the birthday party? Oh, all together. 4, 5, 6, 7. So this is a basic way of explaining it through stories. You can talk about, oh, there were 3 teddy bears that went to a playground, 4 teddy bears that went to a playground. 3 fishes went swimming, 4 more fishes came swimming. How many are in the pond? Just, there's so many different stories and ways of explaining it. You want to expose the students to as many different ways as you can, so the students have a really good understanding of what you're talking about. I will show you one of our number bond templates. Okay, so I have in my hand, these templates are straight out of Engage New York. I've laminated some, so this is one way. Again, you can hold these in many different ways, so the kids are exposed to the different ways of looking at them and really understanding that part-whole relationship. There are these are also from Engage New York for target practice. What you would do is you would write the number, for example, if the number we're working on is number 7, you would write the number 7 here, and that would be their target. They would try to find all the different ways they can make that number 7. This is again to help build that fluency. Here's another one with squares. Again, you could turn them any way you want. So another thing we can do when you're doing something like this, for example, let's say we're working on the number 7 and number 7 is our target. You can use dice. So you would use a regular dice, just roll the dice. What did you get? 3. Then you would write 3 as one of the parts. That's one of the parts. What's the other part to get to 7? Then you can use your counting on strategy, right? You had 3, 4, 5, 6, 7. How many did you use to get to 7? 4. So it is completely, again, it's completely okay and normal for them to use their fingers because they're getting to the answers. And the more they see these numbers together, they will not need to use their fingers anymore. It's just all about repetition. It's all about exposure and practice. Another thing that we use to find partners and build this relationship of part-whole is using two-sided counters. I'll show you what that looks like right now. Double-sided counters, and these are fantastic because dice might be limiting, but these you can use for any number combination that you want. So for example, if I wanted to use smaller numbers, let's say I wanted to use 5, you couldn't use the dice unless, well, actually you could, because you could just cover one side of the dice that you don't want to use. So take that back, you could still use the dice. But this is really nice because it provides for a different way to use it. You will get bored if you're doing it the same way on only using the dice all the time or only using your base 10 blocks all the time. You want to use as many different manipulatives, so the kids are kind of practicing the similar skills, but they're excited and not bored because they're using something different. So the way I would use these are, if, for example, if I was still working on the number 7, I would give each student 7 counters. 1, 2, 3, 4, 5, 6, 7. Okay, please excuse that some of these are beaten up because they've been used a lot and they have some markings on them and they're not in the best condition, but the kids know what to do with them. So you would give them the target number. So for example, I have 7 in my hand, and what the kids would do is they would just shake it up with 2 hands cupped together. I'm not doing it right now because I'm holding the camera with my other hand, and then they would dump it, and then they would just kind of like fix it to see what fell down, and then they would put the red ones together and the white ones together, and they would say, oh, 4 is one part, and then they would write 4 as one part, and then 3 as the other part. 4 and 3 is 7. So that's just another way to do it, and they would keep doing that until they have covered all of them. One of the recent lesson plans in Engage New York actually had this chart. I will show you what that looks like, which gave the kids a lot of practice with this. I'm going to cover the name of the student. So the title was saying shake those discs, and the focus number was number 6, and what the kids did was shake those discs and see what came up, and then they would put an X to show which one they got. You know, 0 and 6 or 5 and 1 or 4 and 2 or 3 and 3, all the combinations, and it looks like this student got 2 and 4s mostly all the way up to the top. So again, this just gives them lots and lots of practice to see, oh, 4 and 2. Oh, we got a 4 and 2 made 6. 2 and 4 made 6. 3 and 3 made 6. Oh, 0 and 6 made 6. So they see all of these combinations, and the more they're exposed to it, the more they're going to remember, oh, 4 and 2 did make 6. I don't really need to count all my fingers. So it might start with 4 and 2. It might be like 1, 2, 3, 4, 5, 6. Then it might turn into, oh, 4, 5, 6. Then hopefully it's just going to be, oh, 4 and 2 is 6. I've seen those numbers together so many times. Now I know I've mastered it. I got it. 4 and 2 is 6. So this way, when it comes to adding bigger numbers, they're going to be able to really apply that Think 10 strategy. In addition to, I think it's great to get the kids to practice telling stories. We don't want to only focus on these skills, but you can still focus on doing things like that through stories. So if you have, teddy bear counters in the classroom, if you have small animals, zoo animals, farm animals, whatever you have available to you. And if you don't have anything, you could just make up the story. You could just use the kids in the classroom if you wanted to. You could do it with hula hoops. I've done that in the past where we had 3 hula hoops showing the part whole. And we would say, okay, 2 girls went to a birthday party and then 4 boys went to a birthday party. How many kids are at the birthday party altogether? And the kids really like that because they're actually physically involved inside the story. So that's a really fun way to do it. You can use teddy bear counters and tell them, okay, you have 5 teddy bears. I want you to tell me a story. And it's up to them. They come up with the story. I'm like, where do you want to go? Where's the setting? So you can include a little bit of literacy in there. The characters, who are the characters? The characters are the bears. What's the setting? Oh, they're going to a playground. I don't know, depends on what the kids want to say. Let's say, for example, once upon a time, there were 5 teddy bears. 2 teddy bears decided to go to school, and 3 teddy bears went to the grocery store. That's a lame story, but here you go. So what are the 2 parts? Oh, 2 and 3. How many were there all together? There were 5. And it's okay to write it this way or the other way. It doesn't matter as long as the kids understand part, whole. You might want to give them just this and say, there were 5 bears. 2 went to the park. How many are left? So they would have to figure this out. This would be a little bit more complex. Giving them all of the counters would be a little bit easier. So we start from the very concrete and we build up to the abstract. And at the end, that means they could do this in their head like that. How can parents help? Parents can be very, 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 very helpful at home without putting pressure on the students, without telling them, oh, don't use your fingers. This needs to be happening in your head. Do your best not to stress out your child. Make it fun. Play a game. Oh, let's play a game. Our game is called number 5. Today we're going to play the 5 game. I say a number, you say the other part of that 5 family. And we also use our fingers to work on this in the classroom. If our focus number is 5, I would say, oh, 1 part is 5. What's the other part? You can see it right there. 4. 1 and 4 is 5. You got it. Let's do that with 7. What are the 2 numbers that are hiding in 7? Oh, 2 and 5 are 7. What else is hiding in 7? 1 and 6 are hiding in 7. So finding ways to make this fun, always having it in the back of your head to take these numbers apart. Oh, we have, 8 pieces of candy. How do you want to share it with you and me? How many should you get? How many should I get? So what were the 2 parts? What were the numbers that were hiding within 8? What are the 2 parts of 8? What would make it fair, equal, not equal? Just have it on the back of your head. Make it fun. Don't make it drill and kill and memorize. If you have any questions or if you need any other tips or ideas on how to teach this, please comment below. I hope this video was helpful. Thank you for watching. As always, happy teaching.